Bienvenidos, Hushamadid, and welcome UMGC learners from CMIT-455, section 6380, for the spring 2021 semester. This is the Cisco Networking Academy CCNP ENCOR version 8 curriculum, and in this supplemental video tutorial, we're going to be taking another look at Chapter 4, in which we covered multiple spanning tree. Now, multiple spanning tree is commonly known as 802.1s. However, as mentioned in the Zoom session last night, remember that it has been rolled into the 802.1q 2005 standard. And so that is where you'll find multiple spanning tree defined by the IEEE. Now, interestingly enough, we got down to the configuration part last night, and MST 0, which you'll hear referred to as the common internal spanning tree, or the CIST, which is where all VLANs that are not assigned to a specific instance, those end up in MST 0. We saw MST 1 that we had created, but then we never saw MST 2. And the reason for that was I had assumed that I had configured VLANs on those switches and had not done that configuration. And so we're going to see that the VLAN, and this is what I love to call a fortuitous failure, right? Great learning event. We're going to see that the VLANs, if not created, in that instances that, MST 2, 3, 4, 5, whatever the case may be, is using or referring to those VLANs, that MST instance is not going to show up. And so we're going to walk through some configuration work. And so in this activity, so that we have a better view of what's going on, I've got 3 switches. Now, these switches are configured like you would have any access layer switch to 2 distribution layer switches. And everything here is layer 2, right? So all of our links are layer 2. In fact, this is an Ether channel bundle with 16 links, LACP, of which only 8 are active. Remember, you can have 16 in the bundle with only 8 active at any given time. So we've got distribution layer 1, we've got distribution, I shouldn't say layer 1, distribution switch 1, distribution switch 2, and then we've got our access layer switch 1, or just A1 here. Now, we've already created, so I've removed the mystery and I've created the VLANs, all 100 VLANs on all 3 switches. So we're not going to run into any issues, and I'll demo, like, if we were to create an MSTI instance and map VLAN 500 to it, but we don't have VLAN 500 created, we're going to see what happens. All right, so this is our configuration right here. All the trunk links are set up. Everything is already fired up and ready to go so that we can focus on the MST multiple spanning tree configuration. So here we are on distro switch 1. And remember, right now, what version of spanning tree are we running? Well, if I say show spanning tree, you can see here, it's the IEEE, and that's what shows up in the output. Now, what is this referring to? Remember, Radia Perlman created the spanning tree protocol. It was ratified and standardized with the IEEE as 802.1 capital D, as in David. So 802.1D was the original IEEE ratified, standardized version of the spanning tree protocol. The problem was that it supported a single tree, a single spanning tree path. You couldn't do load balancing with the VLANs and maybe block some VLANs from the left-hand side or block some from the right-hand side. And so Cisco said, well, that's great, but we're going to go ahead and roll out RPVST. And so if I was to write this out real quick and give you sort of an abbreviated version, so the IEEE, and I'll just put an I right here, the IEEE standardized 802.1 capital D. Now, this was also referred to as common spanning tree, or CST, because of the fact that whichever switch was the root bridge, the topology was built off of that. There was no way to do layer 2 traffic engineering. And Cisco said, and that's a D right there, by the way, Cisco said, okay, that's a good start, but we like per VLAN spanning tree. And remember, PVST was referring to when Cisco had ISL, and this is a legacy trunking encapsulation that's no longer around on newer Cisco gear, and PVST plus. And that plus sign, remember we said that that is all about 802.1q encapsulation. So 802.1q encapsulation. But the key here was this per VLAN, the PV, per VLAN spanning tree. So I could theoretically allow some traffic to flow in the topology that we have here. I could allow some VLANs to go this way and then some to go this way, instead of maybe having that link blocked right there and all traffic using this one link, where this other link over here is just sitting there doing nothing. And so Cisco said, well, we're going to do PVST, PVST plus. And that is what you see here. If I say show spanning tree summary, you're going to see that it says it's in PVST mode, right? And so this is sort of the Cisco secret sauce. Well, right away, everybody knew that there were limitations with regular spanning tree. So we came out with the IEEE standard, which was 802.1 lowercase w, and that was the rapid spanning tree protocol. Now, it wasn't referred to as CST, right? This is not what it was referred to. However, it still only supported a single tree, a single spanning tree topology. So all VLANs would follow a single path. And Cisco looked at that again and said, hey, we're not big fans of this, so we're going to create rapid per VLAN spanning tree or rapid per VLAN spanning tree plus. And again, it was basically leveraging the rapid spanning tree protocol. Backbone fast and uplink fast got rolled into the standard. So those disappeared from the spanning tree toolkit in terms of running RPVST or RPVST plus. And again, without the plus sign, we were talking about ISL, but that's long gone. Now we're talking about 802.1q, which is why the text is going to refer to RPVST plus and PVST plus. Now, this was great, right? The problem was that with Cisco's implementation, you had an instance of spanning tree for every single VLAN. Now, with 2 or 3 VLANs, not a big deal. With 200 or 300 VLANs or 2,000 or 3,000 VLANs, that might become a concern from an overhead perspective and an administration perspective. So you had two ends of the spectrum here. You had the IEEE, who basically said, yeah, we don't need to load balance. We'll just have all VLANs follow one spanning tree topology, and that's what you're going to get. And then you had Cisco saying, no, we need an instance of spanning tree for every single VLAN that's been instantiated on the switch. And so, again, you had two extremes. We're going to do it just one way and one way only, and no, we're going to have it so that every single instance of, or every single VLAN has an instance of spanning tree that's running for it. And so they finally came to an agreement, the IEEE, and you shouldn't say there was an agreement that they came to, but basically what ended up happening was Cisco and the IEEE, and it was Cisco's invention, and they came up with the multiple instance spanning tree protocol, and this was 802.1s, right? And that's what we're focused on here. And remember, it's been rolled into the 802.1q-2005 standard. And the IEEE standard initially was 802.1s. And this was a great compromise between these two extremes up here. Because what we're going to do now is we're going to be creating what are called MSTIs, multiple spanning tree instances. And each instance can have one or more VLANs. And again, when we're talking about instances other than MST0, which is that common internal spanning tree, which is where all VLANs are initially assigned. When we're talking about MST1 or MST2 or MST3, and I believe the limitation is 16 MSTIs on Cisco platforms. But once you start creating these MSTIs, the VLANs need to exist, as we saw in the video last night, where MSTI 1 was created, and we referenced VLAN 1 and it worked, but then I referenced other VLANs that I thought I had created but that I didn't create, and then we ended up with no way to see output for show spanning tree, what was it, MST config. We were unable to see MST2. We just didn't see it, and it was because the VLANs didn't exist. So as soon as you create those VLANs, then that MST instance is going to pop up and you're going to be able to see information on it. But here's the key point. We went from these two extremes to a great compromise here. And so what we do is we create MSTIs. We create an instance of spanning tree, and specifically multiple spanning tree under the covers is running the rapid spanning tree protocol, 802.1w. That is what is running underneath multiple spanning tree. And so you can think of the configuration syntax as sort of a wrapper syntax that we create that says, I'm going to create an instance of multiple spanning tree, which again is running the rapid spanning tree protocol under the covers. And to that instance, I will assign or map a number of VLANs. And so I can achieve the same result that I did with PVST, PVST plus, or RPVST and RPVST plus, but I don't need an instance of spanning tree for every single VLAN to accomplish that. So in other words, over here on the left-hand side, I can go ahead and create instance 1. And again, it's a multiple spanning tree instance. It's MSTI 1, or MST1 is what we're going to see. It's multiple spanning tree instance 1. And then over here, I could create multiple spanning tree instance 2. And you'll see what I'm referring to here in just a second when I say MST1 and MST2. And so when I say over here, I mean, let's say that we wanted VLANs 1 to 50, 1 through 50, and actually we'll go ahead and we'll say 2 through 50. So 2 through 50 to use this path, and we'll say we've got all these hosts hanging off down here, and all these different VLANs, right? Hundreds of hosts. We want VLANs 2 to 50 to use this path. To use that is going to be the root bridge, meaning that this over here is going to be the blocking port because we're going to use this as the secondary root bridge for instance 1. And so now I've just load balanced, and it doesn't have to be a contiguous block of VLANs. I could say, okay, I want all odd VLANs to use instance 1. So then I would say 1, 3, 5. And again, if we're not using 1, probably shouldn't be using 1, 3, 5, 7. They're all going to be mapped. So we're mapping VLANs to a single instance. And here's the thing. Remember, a multiple spanning tree instance can have multiple VLANs mapped to it. However, we can only associate a VLAN with a single MSTI, a multiple spanning tree instance. So I can't associate VLAN 3 to MSTI 1 and then over here to MSTI 2. It's one or the other. It's going to be associated with multiple spanning tree instance 1 or 2. And then over here, I want VLANs 2, 4, and 6. Right? So now I'm doing layer 2 traffic engineering. And for the traffic that's coming to the right-hand side, this would be the root bridge, and this would be the secondary root bridge. And we're going to see how we would set that up. I'm just going to use a contiguous block to make it easier. But you get the idea, right? We've gotten rid of an instance per VLAN from a spanning tree perspective, and now we're just going to use 2 instances. And remember, there's a third, that common instance spanning tree, MST0, where all VLANs are going to initially reside until we start mapping them to different instances. But we achieve the same goal, which is layer 2 traffic engineering, leveraging each of these uplinks to be able to send traffic for specific VLANs without the overhead of a spanning tree instance for every single VLAN. And so multiple spanning tree, which if you're going to be taking that CCIE lab exam, I would highly recommend that you hammer out the config steps and that you've got everything worked out from a configuration perspective and how to do what you're about to see here in that load balancing. So let's dive into the command line here. Enough of the background there. So here I am on distro switch number 1. And let's go from user exec to privilege exec into global config, and we're basically going to say spanning tree MST configuration. Now, this command is what puts me into MST sub-configuration mode. And you can see there, config-MST. And it's here where I can assign a name to the configuration. And now we're going to be configuring what's referred to as an MST region. And a region, or the members of a region, and the region is defined by all of the members which have the exact same configuration. And so one of the ways, and this is an optional step, is I can set a name in the configuration, which is always a good idea, right? And I'll just say name HQ as if it's headquarters. Now, the next thing that we're going to do is we're going to put a revision number. And when we come in, we would change this revision number if we're making changes at a later date. So let's just go ahead and we'll start with revision 10. So if I came back in at a later date and made additional changes, I would make it revision 11. And so what I'm going to do now is, you can see we've got that instance command there. So here's where I create the instance referencing an instance number, and we'll say the number is going to be 1. So multiple spanning tree instance 1 is going to have VLANs 2, whoops, not 59, 2 through 50 mapped to it. It's as simple as that. And then we're going to have a second instance, instance 2, which would have VLANs 51 to 100 mapped to it. And so now we've created our 2 instances of spanning tree. Again, remember, it's running rapid spanning tree protocol under the covers here. And you should get the feeling like, yeah, I can kind of see what's going on here. It's like we've got this kind of configuration commands, but really behind the scenes, it's rapid spanning tree that's running. So here's what we're going to do. I'm on distro switch 1. So I'm going to go ahead and say, you can say exit or end to back out here. But let me go ahead and say, let's look at some show commands right now since we're on the first switch. So I can say, what does my current multiple spanning tree config look like? And there it is. There's MSTI 0, or MST0 is what we're going to see in some of the output. But that's the multiple spanning tree instance 0. And as I told you, only one instance is configured right now because we haven't exited out yet. You'll notice no name is configured, the revision number is 0, and the instance is configured is 1. That is our CIST, MST0, where all VLANs that are not mapped to another instance are going to reside. And it's not until I exit out here that we would be able to see the committed changes. So if I was to say show pending, right? So what are my pending changes? Well, the pending changes are going to be all those changes we just made. And you can see the name is now HQ. The revision number is 10. We've got 3 instances configured, 0, 1, and 2. And look what's left over here for VLANs mapped to instance 0. It's 1, 101, because 2 to 100, we've mapped out to instance 1 and 2 respectively, 2 to 50 and 51 to 100. So hopefully you've got a good feel now that, all right, I kind of see what we're doing here. We're just creating instances of spanning tree and then mapping the VLANs to it, instead of letting Cisco create an instance of spanning tree for every single VLAN. Okay, so let's punch out of here. Whoops, sorry. We'll punch out of here by saying end, right? And that takes me back to, well, I should have said exit. Takes me back to privilege exec. Let's get back into global config, where I haven't changed the spanning tree mode yet. Right? I haven't changed the spanning tree mode yet, but if I was to jump back in here and say spanning tree MST configuration and say show current, what would you anticipate we're going to see, right? Remember, as soon as I exited out of that spanning tree MST configuration subconfig mode, now my changes have been committed. They're no longer pending. Now they're in play here, right? So everything's ready to go. So what do we need to do though? Well, remember, this is spanning tree. I need a root bridge. I need a secondary root bridge. And our access layer is definitely not going to be the root bridge. And so in order to make sure that we are, and the word is escaping me right here, to make sure that we are making this topology deterministic. That's the word I was looking for. We want to hard code who the root bridge is going to be and who the secondary root bridge is going to be, because then it's predictable. It's deterministic. If a link goes down, I know exactly which links are going to come back up, who the new root bridge is going to be. Don't leave it to chance, because as we saw, if the priorities are all the same at 32,768, and you just turn everything on and plug stuff in and configure a bunch of trunk links, you're leaving your root bridge and secondary root bridge configuration to chance based on MAC addresses. And remember, lower is always better. There will never be a tie, and lower MAC addresses are typically, generally going to be found on older switches. So we don't want to leave that to chance. So here's what we're going to do. I'm going to go ahead and say exit. And actually, before I do that, we said we see the current. Okay, so what's pending now? Well, as you would anticipate, we shouldn't see anything pending, right? So here's my configuration. Everything is set up. We're all ready to go. And we looked at the current. And so let's go ahead. Let's punch out here back to global config. And again, spanning tree MST1, instance 1. I'm referencing the instance here, right? And so what am I going to do? I am going to make the priority on distro 1 0, the lowest of the spanning tree priorities that are available. And so for instance 1, distro switch 1 will be the root bridge. And then for instance 2, it's going to be the secondary root bridge. Now I use 0 to make sure that it is abundantly clear that is the root bridge. And that's what I want to be the root bridge. The next value up, remember the values are in increments of 4096. So the next value up would be 4096. That means for distro switch 1, I'm the root bridge for MST instance 1, and I'm the secondary root bridge for MST instance 2. Again, make it predictable, make it deterministic. And so now we've taken care of the configuration on the distro switch. All right, so what's next? Well, we're going to walk through these same steps, but a little bit quicker here on distro switch 2, keeping in mind that this is going to be the root bridge for instance 2 and the secondary root bridge for instance 1. So we'll have a little bit of a difference there. But not much else is going to be different. So spanning tree MST configuration. I'm going to say name HQ because these are in the same multiple spanning tree region. They're going to have the same configuration information. The revision number was 10. And then we went right into the instances. So I'm going to say instance 1 had VLANs 2 to 50. And instance 2 had VLAN, oops, sorry. Misspelt that. Instance 2 had VLANs 51 to 100. Again, remember, the common internal spanning tree instance, or MST0, is going to have all other VLANs. And initially, it has all of the VLANs. And then the only thing left for me to do here is I could say, sorry, show pending. And you can see those are my pending changes. If I say show current, we have nothing configured right now. So we just see what the default is. Well, let's punch out of here. Now that configuration is our current configuration. And so I'm going to say spanning tree MST for instance 1, we are going to be priority 4096, right? We're the secondary over here for instance 1. And then spanning tree MST2 for instance 2, priority 0, because we are the root bridge for instance 2, meaning we're going to be drawing that traffic from VLANs 51 to 100 in the spanning tree topology will be coming to distro 2. And then VLANs 2 to 50 will be going to distro 1. And so now we're going to step back and we're going to do the same thing on the access layer switch. But the access layer switch, we don't ever want this to become the root bridge or the secondary root bridge. And so what we would do here with the spanning tree priority is we're going to configure it to be the highest value of 61440. So spanning tree MST configuration, and then the name is going to be HQ, and then our revision number is going to be 10. For instance 1, we're going to have, what was I thinking? VLAN, VLAN, there we go, VLAN 2 to 50. And instance 2 maps out for VLANs 51 to 100. And then as soon as we exit out, we're going to set the priority. So we say exit, and then it's going to be spanning tree MST priority. And here's where, spanning tree MST1 priority. So I don't want it to be the root bridge or the secondary root bridge. So I set it to 61440, and then I'm going to run the same command over here again on the access layer switch for instance 2. Now, we're still not running multiple spanning tree yet because we haven't changed the mode on any of the switches. And so if I was to go to privilege exec and say show spanning tree summary, what do we see? And here's what I told you. Switch is in PVST mode, right? Cisco's secret sauce. And we've got 100 VLANs configured here. And take a look at this. Cisco created an instance of spanning tree for every single VLAN, all 100 of them. There they are, right? That's a lot of overhead when the number of possible topologies in our configuration, the triangle that we have, there's 3 possible topologies. And here's what I mean by that, right? So if we have DSW or distro 1, distro 2, and then they connect into our access layer down here, there's only 3 different options, right? Either this is going to be the root bridge, and then one of these 2 would be the secondary, and then the topology would be formed on that. Or this is going to be the root bridge. And again, for the VLANs in question, the VLANs that are mapped to the multiple spanning tree instances. Or this is going to be the root bridge, right? And so we know that we don't want the access layer to ever become the root bridge, so we give it the highest possible priority value of 61440. And we hard code for VLANs 2 to 50, we hard code that to 0 here, and then 4096 over here, and then we do the opposite for VLANs. If I was to change color for VLANs 51 to 100, we do the opposite where we say the priority is 0 here, guaranteeing root bridge election for that MSTI. That's VLANs 51 to 100, and then we set it to 4096 over here. And so then we know exactly what's going to happen. And what would happen for VLANs? What would the topology look like here in terms of port roles and states? Well, for VLANs, MSTI 2 or MST2, which is going to be VLANs 51 to 100, if this is my root bridge, then these ports are guaranteed to be designated ports for the VLANs in question. And if those are my designated ports and this is the root bridge for VLANs 51 to 100, this is going to be the root port. And this is going to be the root port. And then we have this segment right here where we need to determine which switch has a superior bridge ID. And with the priority assignment, we've guaranteed that this would be, on this segment, the designated port, and that's my blocking port. So for VLANs 51 to 100, the traffic is guaranteed to flow that direction. Switch back to yellow. For VLANs 2 to 50, here's what the spanning tree topology looks like. If this is my root bridge, then these are both designated ports. Again, for the VLANs mapped to the instance, 2 to 50. We know that this is going to be the root port. We know that this is going to be the root port. And now we have this segment here where we need to figure out which switch is sending the superior BPDU. Well, we already know that 4096 is a better priority value than 61.440. So this is going to be the designated port on this segment, and down here on the access layer, we have the blocking link. So for both multiple spanning tree instances, 1 and 2, right? This is instance 1, and then instance 2, the link that's blocking, or the port that's blocking down here, the alternate port is going to be on the access layer side, right? And up here, we're going to have our designated ports. And so now we can look at this and easily determine if a link were to fail, what's going to happen. But by hard coding the values, right, 61.440, we now have a predictable, deterministic spanning tree layer 2 topology by creating 2 multiple spanning tree instances, again, running rapid spanning tree protocol behind the scenes, right, behind the curtain. And we're mapping all of these VLANs, but we only need 2 instances to keep track of anything, compared to what you're seeing over here, where we have an instance of spanning tree for every single VLAN. All right, so the final thing left for us to do, and again, as I said last night, I would highly recommend an outage window if this is something you're going to pursue in production outside of a lab environment. And the final thing to say is spanning tree mode MST. And I'm going to run that as quick as I can here on some of these other guys. Spanning tree mode MST. And then on access layer 2, spanning tree mode MST. Now, what we've got going on behind the scenes, and what I'm hoping is going to take place rather quickly here, and let's go ahead and get out of global config into privilege exec. And so let me say show spanning tree MST config. So here is my spanning tree, my multiple spanning tree configuration. Now what does show spanning tree look like? Well, now you can see we have MST0. We're using the multiple spanning tree protocol. And again, remember, for MST0, right, that common internal spanning tree where all VLANs that aren't assigned to another instance reside, it just so happens that this switch, the access layer switch, turned out to be the root. So maybe you want to change that. And there's MST1. And again, you can see the root port is fast Ethernet 103. And that would go up to the left-hand side of our connectivity. And the alternate blocking port is fast Ethernet 014, which goes to distribution switch 2. And so I have hard-coded in my priority values. The tree has been formulated, and it's just the opposite for MST2, where the link going to distro 1 is alternate blocking, and the link going to distro 2 is the root forwarding. And again, I'm using single links here. You could have multiple links bundled into a port channel, and you would end up with the same result, right? As long as we're using the same priority values for spanning tree. Let's take a look at show spanning tree MST instance 1, right? So maybe you only want to see instance 1. So here it shows me the VLANs that are mapped. It shows me the priority values, right? It shows me, what else do we have? Again, the port states that we can see. If we looked at MST2, we would see similar output. We could also say show spanning tree, what's another command? Summary. Let's say show spanning tree summary, and you can see here, switches in MST mode IEEE standard, because Cisco created multiple spanning tree and then ultimately is using the 802.1q 2005 standard, right, or the 802.1s as it's commonly referred to, is using that standard. And you can see that I'm the root bridge for MST0. Well, if we ran that up here and said show spanning tree summary, we should see that this switch is the root bridge for MST1, instance 1 for VLANs 2 to 50. And over here, and let's say show spanning tree summary, you can see that this switch is the root bridge for MST2. And this is our MST region. These 3 switches make up a region. In fact, if you had a switch that wasn't a member of this region connect to this region, it would see the region, these three switches, it sees it as a single logical switch. It doesn't see them as three individual switches. It's going to see it as a single logical switch. All right, so the final thing that I wanted to show you was, and I'm drawing a blank right now, was we're going to create an MST instance and we're going to map a VLAN to it that doesn't exist, that we haven't created. And so if I was to go to the access layer and say show VLAN brief, we can see that we've got VLANs 1 to 100 here, and I'll just kind of hold down the space bar and let this play out. So there is no VLAN 250. So what if I were to do this? What if I was to go into global config and say, sorry, not standing tree. We're going to say spanning tree MST configuration, right? The name we used was HQ. And what if I wanted to create a new instance, right? If I wanted to map instance, we'll call it, and let's actually see, what is the limitation? Well, this shows 4096. I think you can pick numbers as high as 4094. I said 4096, I meant 4094. However, I think you're limited to about 16 actual instances. So we'll just call this instance 250. And we're going to say that instance 250 has VLAN 250 mapped to it, right? Now, what do I want to do? Well, I've changed things. So I want to change my revision number to 11. So again, if I say show current, we see the current configuration. If I say show pending, we're going to see the change I just made in addition to what is the current configuration. So let me say end. Let's come over here and we're going to do the same thing on the access layer switch. And we'll get into global config. We'll say spanning tree, MST configuration. The HQ was the name that we were using. And we'll go ahead and say instance 250, VLAN 250. And let's change our revision number to 11. And then we'll say end. And we'll come over to distro 1 to wrap things up here. Spanning tree MST configuration, instance 250, VLAN 250, and revision number 11. And then we'll say end. And so you'll remember VLAN 250 doesn't exist. So when I say show spanning tree, we see MST0, we see MST1, and we see MST2, and that is it. If the VLAN isn't created and doesn't actually exist, you can go in, create the MST configuration. However, you're not going to see that multiple spanning tree instance 250 reflected here. So let's prove that that's actually a true statement. So we'll get into global config. I'll say VLAN 250. And then end, and we'll come over here, and I'll get into global config and say VLAN 250, and then end, and then we'll end up on the access layer switch here, get into global config, VLAN 250, and again, this is where I went wrong last night, thinking I had the 100 VLANs created when they weren't created. And so now if you were to say show spanning tree summary, we see MST 0, 1, 2, and 250. If I said show spanning tree, we would see additional information here for MST1, MST2, and now finally MST250. All right, well, hopefully this explanation and this sort of demo here of how to configure multiple spanning tree and a little bit of the history of spanning tree and why multiple spanning tree is so much better from a resource perspective than per VLAN spanning tree or rapid per VLAN spanning tree, especially if your use case is you have hundreds of VLANs. Now, if you've got 10 VLANs, I'm not sure that running multiple spanning tree, again, it's all about use case. If you've got 10 VLANs, maybe even if you've got 20 VLANs, maybe multiple spanning tree is not going to be the play for you. Maybe it is rapid per VLAN spanning tree plus. You know, on newer switches, they've got some pretty serious horsepower. But when you start talking hundreds of VLANs, that's when not only from an overhead perspective, but an administrative perspective, multiple spanning tree may be what you want to do. And so again, you've got a greenfield environment or you're looking to upgrade, you saw I staged everything in the config, and it wasn't until I said spanning tree mode MST that it kicked in the multiple spanning tree configuration. So you could theoretically stage everything and in a change window, go ahead and execute. Again, it's all about the use case. So that is going to wrap up this supplemental video tutorial where we had a laser focus on multiple spanning tree 802.1s, which is now part of the IEEE 802.1q 2005 standard. And we covered a ton of ground. Hopefully this made multiple spanning tree a little easier to understand, and hopefully you can see the benefits of why it would be used. All right, thanks so much for watching, and I hope to see you in the next video.